Hi, this is Pat Gahn here with the Ubuntu Developer Summit, June 2014. We've got Serge Hallen and Stefan Graber here to do some demos for you around containers around LXC. The session's called Clone Snapshots and Nesting. Oh my! So I'll just hand it to Serge to get started.
Thanks, Pat. So I'm Serge. I'm just going to show some basic usage of LXC in Trusty. I fired up a fresh VM here. It's just a clone from a base Trusty VM. So I'm going to start by installing LXC. It should install everything we need, including the cgroup manager. I need a cough button. And install QEMU utils. I didn't think we did that yet until utopic. Okay.
So, Serge, there's been a request to increase the font size. Is that possible?
Yes. Let's see. Is that better?
One more.
One more.
Maybe? That's nice.
All right. Okay, so I've installed LXC. I'm going to create my first container. create -t download -n. I'm going to call it U1 because I just always call them that. I'm using what's called the download template. So LXC used to use templates to create your containers, and that was because in the old days you had to grab an image and modify it a bunch to make it run in containers. That's not really the case anymore. And so now I almost always use the download template, which just grabs some pre-built images, which are basically the exact same thing as the cloud images, or just a stock bootstrapped image. So I'm going to take an Ubuntu Trusty AMD 64 image, and it'll download that and create the container. And this first time it has to download it from the server. After that, it'll be cached. Oh no, I hope the server isn't.
So, Serge, there's people commenting on your fabulous colors. I've pointed out that they should just be happy you're able to share and in a hangout. So.
For red?
No! Oh God, no! Put it back. Oh.
All right. So the container's installed and ready. I'm going to start it up. And if I just say LXC start -n for name U1, then it just starts it up and gives me a console like this. Default password and username are Ubuntu. And you can see all it's running is what's in the container. And network is private, etc. So I'll power that off. Now,
why did you power it off?
Because now I'm going to start it again, but start it in the background with -d. Okay. And now I can attach to that in a couple of ways. The old standby was using LXC console, which connects to a TTY in the container. And you get out of that by doing Control-A and close bracket. Nope, Control-A and open bracket. I forget how to do it. But it tells you when you start it up, so let's see. Control-A-Q, that's it. Okay, so now we will attach.
Control-A-Q? Okay.
Control-A and then a Q, yep. And the control A, you can modify that with you can do LXC console -E, and I assume like U would make control U be it.
That just don't.
Yeah. Okay, so now we're going to use LXC attach, which is new to certainly over precise. It's new to Trusty, and it will spawn a new shell in the namespaces of the container and under the privileges of the container without attaching to one of the TTYs in the container. And so I'm root in the container. There we go. And then I can externally stop a container using LXC stop. Now that does a nice reboot, nice shutdown of the container. If it was hung somehow, if something went wrong in user space in the container, I could do -K to forcibly kill it. Now the way that built a container is under var lib LXC, there's a U1 directory, which has a config file, which Stefan is going to go over to the contents of later on. And there's a rootfs, which is just a directory containing the rootfs of the container. When you start the container, it pivot roots into this rootfs directory so that becomes the root of it. Okay, so since that is just a normal directory and my file system is ext4, I don't have built-in snapshotting. So if I want to do a snapshot clone of a container, it's going to use overlayfs by default. And so what I'm doing here is there are long versions of these arguments, but I never remember them, so I didn't want to try and remember them on the fly. But I think it's --snapshot --old u1 --new u11 is going to create me a container called u11. So if I go again under var lib LXC, I go into u11, the rootfs is now empty, and there's a delta0 directory where changes over the original container are going to show up. And so in the container configuration, the rootfs is listed as an overlayfs mount where u1's rootfs will be read-only underneath delta0 in u11, which will be read-write. So now if I start that container up, it's just like anything else. I can practice my typing. And so now if I start the original container u1 back up, that file did not exist there. But if I now create a file in here, you'll see that it shows up in the snapshot container, the clone container. And that's because this is overlayfs, and so that's one of its limitations. So when you use overlayfs container clones, what you really want to do is create a base container and then create the clones and only use the clones from then on. Because if you modify the underlying container to update it or something, you can really confuse the clone.
So
especially
the reason being that the first container won't contain
the reason being that the second one may have some files expecting to still be whatever old version of something in the old container was, whereas the underlying file system has new versions. So things can just become inconsistent.
But it doesn't prevent you from doing it. So
it doesn't prevent you from doing it.
Why not?
Because that's the nature of overlayfs. It's a simple stackable file system. But on the bright side, what that means is that
there've been a couple. There was a question on IRC, but it looks like it's been answered about LXC attaching as a non-root user.
Okay. So you can see that the snapshot container is tiny compared to the original one. So if you're going to create a bunch of containers that are identical, that's one way to go about it. Now, based on this, actually using snapshot clones, what you can then do is create what are actually called snapshots. There's a command called LXC snapshot, and all it does is create snapshot clones underneath a private path of the container. So I've got my U11 container. I'm going to make a...
So this is about taking a snapshot of an existing container?
Right.
Okay.
So if I list these now, you can... Oops, I didn't add the comment originally. So now snap0 is just a snapshot of the container, which I can then later restore. So if I now start up the container and make some changes, I don't know. I can snapshot it again.
What? Why did you say, what just happened?
I forgot to write out a comment first.
Oh, okay.
-n U11 -c comments. And so now, when I list my snapshots, I've got 2 of them there. And now I can restore the first one by saying -r snap0.
So can I ask you a question, Serge?
Yes.
So you have snap 1 and you have snap 0, and in between it says second comment. So why? What is that showing? What the difference is?
Right. You can add. It's just this. This was not meant to be an advanced user space tool, which is the building blocks or something more advanced. So all you can take a plain text file and tie it to a commit. And so second commit is the commit message attached to snap 1.
Okay. Okay. Oh yeah. Sorry, I see that up there. Okay.
Right. And I'd forgotten to attach a comment to snap0, so there's no comment there.
Okay. Okay. I got it. All right.
But so now I've reverted snap0, and so now we'll see that the file I created was no longer there. Okay, now that's showing the basic directory-backed and overlay-fs-backed containers. Now, there's a whole bunch of other possibilities. I'm just going to show 2 more. I've got a second disk in this VM called VDB. So what I'm going to do is I'm going to, first off, install LVM2, and then create a VG on VDB. Didn't really need a new init ramfs, but
Clearly, it thinks you do.
okay, so I'm going to create the PV and create a VG called LXC. So now what I can do is LXC create, I can say I think dash backing store would be the full word, or $B is a short. LVM -t download -n LVM1. And then the things I picked through a menu before, I can do shorthand on a command line.
Serge, I don't know how you keep all these options straight in your head.
I just type them out a lot. So it created the LV and is unpacking the rootfs into there. And now if we look, we've got a new LV called dev LXC LVM1 for the LVM1 container. And when we start that one, you can see that our rootfs is now on dev LXC LVM1. And so this is one way to actually constrain a VM or a container to a certain amount of disk space.
So what are the other ways to do that? Is this the way to do that?
This is probably the best way. You can use a loopback device, and I think there's a way to do it with Btrfs with subvolume quotas, but I'm not sure.
But this is the preferred way. Okay.
Yeah. Now, there's some other options you can give when you do LVM.
So Serge, can I ask you
Yeah.
a question?
Mm-hmm.
So there's a question from IRC from, I can't always pronounce these, IRC Nix, G. DeSantis. Question, does AUFS have the same gotcha on shared files as OverlayFS?
It does. They're both just stacking file systems. So yeah, if you change the underlying file system, if the stacked file, the clone is shut down, in most cases, it'll end up okay. But I just wouldn't want to risk it, and especially if you've made changes to something that then gets updated in the underlying one, the merge, or if DPKG did some merging of custom changes, you'll get the wrong customized version in the overlay afterwards. Okay, so when you're creating a LVM-backed container, you can specify a custom size. The default is 1 gig, which you saw with a DF, I think. And you can pick another FS type. The default is ext4. I often use XFS. And then one other thing you can use is thin pool, which one advantage. So with LVM, you've got an advantage of quick snapshots again. So I can LXC clone LVM1-N LVM2. Done. I can create another one. And now with these, I can actually change LVM1 without affecting LVM2 and LVM3. They're actually nice, proper snapshots. What I can't do right now is take one of those clones and create a new clone based on it, because LVM, by default, doesn't allow nested snapshots, or snapshots of snapshots. If you use thin pools, I think you can then do it, but I have not really used them. Are there any questions on that? Because I'm about to wipe out the... I'll assume not. Okay.
Yeah, there aren't any others. I paused for a second because there's just a slight delay.
Right.
Okay. Oh, so B. Mulan has a question about SDN taking over in the data center. What is OpenStack?
I'm sorry, about what?
Someone has a question about
Doesn't seem to be
SDN.
related to LXC.
It's not related, so it's not directly related to the topic we're covering. So I'll handle it.
Okay, yeah. So I will fdisk dev fdb. And create a file system.
No, so what are you up to now, Serge?
Creating a Btrfs file system to use as. Oh.
And this is the other option you are giving for being able to do the snapshotting.
Mm-hmm.
Okay.
Busy. Wonder what's running on it. I thought it might not like that, so what I'm going to do is...
So how are you recovering from this? So, this might happen to someone using it. So.
Well, this is just because I had LVM there before, and Btrfs is very careful about where it installs itself.
Okay.
And so I had a feeling this might happen, but I didn't.
So what are you doing now? So you're basically...
I'm just going to create a new...
Cleaning it up. Cleaning it up. Okay.
Yeah. Because I don't want to deal with it. So I'm going to recreate my partition. That's odd.
What is odd? Tell me.
That it seemed to think there was a file system there, since I just created a brand new backing store for it. That was just random junk. That or my disk reused some. Anyway, so I've got a ButterFS file system. What I'm going to do is mount that under opt. And make an LXC subdirectory there. And now, this is mainly to show one other way of using LXC, which is like I showed you before, varlib LXC is where it normally puts the container on its rootfs. Now with loop device, well, at least with LVM, the rootfs, of course, comes from a device, and so that kind of skirts that. But you can also specify custom LXC paths. And what I've done is I've mounted a ButterFS under opt LXC. And so I'm going to do LXC create. I'm going to specify ButterFS as the backing store because I'm going to want to create snapshots. Download template. I'm going to call it butter1. Then I'm going to say -p for the LXC path. Opt LXC. And now, basically, anytime I do an LXC command to refer to that container, I should add the -p opt LXC. Or I could edit do not have that. I could create a LXC.conf and set LXC.LXC path to point to the new path, and then that would be the default instead of varlib LXC. But I'll just keep typing it out. So LXC start -p opt LXC-n butter1, and again, it just starts up. And now VDB1 shows up as my disk backing my rootfs. Now this has the same advantages as LVM in that I can create snapshots without, and I can update the original without having the update the clone be updated. It has the advantage over LVM that I can snapshot snapshots, and I can just go on and on and on like that. So opt LXC -s-o butter1 -n butter2. And I can just go on, and in this case, I believe each container looks like it's taking up the same amount of space, but ButterFS is using copy on write metadata, so that really butter2 and butter3 are barely taking up any space until you start changing things. And then was there anything else I was going to show on that? I think that was it. I could show updating the original and not having the clones be updated, but I think you'll believe me on that.
I'll trust you for today.
Then I was going to show unprivileged containers from here, but I think we're going to save that for Thursday for the user namespace session. So I'll turn it over to Stefan.
All right, let me, I have you on focus. Let me switch it away. All right, Stefan. I'll make the focus on you now.
Right. So I'm just cleaning up my environment and actually do a demo.
While you get things set up, let me see if there are any questions. So Uralama asked on IRC, question, is this documented anywhere? There are many parameters to deal with. Uralama, I am with you. I was thinking the same way. I know, Stefan, you've done some blogs about this, and there are man pages, but specifically on the recipes you were following, Serge, is that documented? Is there like kind of a...
I'm sorry, I was reading the backlog on IRC. What was that?
So I just pasted the URL on IRC to the blog post series, which is basically as close of a documentation we've got for 1.0 outside of the main pages.
Yeah. Personally, I think it would be really awesome if someone, watching this would actually write down all the commands that Serge typed, so it would be easy to play with it. But that's my dream. So, Uralama, if you want to do it, I'd love it. It'd be awesome. But yeah, like I said, and then also RoadMR said on IRC, Stefan has some blog posts and then also the man pages. But yeah. All right. And then someone else pointed out that they've also ran into the device busy thing. Maddie W. Download isn't a template in Precise. Is there a way to get it on Precise?
We've got a stable PPA with the current 1.0 release available for Precise, and once I actually get around to releasing LXC 104, probably on Thursday, then we plan on pushing that as a backport to Precise as well. But Precise on version of LXC, which is I think 0.7, is pretty old, and we couldn't just backport the download template to that. So instead, we recommend that you just run LXC 1.0 on Precise. Okay, so I'm going to show how container nesting works. Because one cool thing with LXC is that you can actually do containers within containers, etc. And so the machine I'm actually showing stuff in is actually an unprivileged LXC container itself. So then I'm going from there. So the first thing I would do is let's create a new container. So I'm just going to create a new container called nesting.
Now, Stefan, you're doing green font with black background, and is that how you and Serge roll? Like, you kind of just try to do the same but opposite? Sorry.
Okay, so the container has been created. So by default, the container won't let you do nesting. You need to.
Can you make your font bigger?
Even bigger than that? Okay, sure.
One more. Okay, maybe one more.
Seriously?
Seriously, come on. All right, it's lovely. Come on.
So in the container config, you need to set the AppArmor profile to LXC container default with nesting. That's so that the few actions that are required to create a container within a container are actually allowed by AppArmor. The other thing you probably want to add is LXC mount auto equals cgroup colon mixed, so that the cgroup hierarchy is passed inside the container, so that you can create subcgroups within that container. With that being done, I can just start the nesting container, go inside it.
Now, Stefan, was the nesting of containers, was that something new and trusty?
No, it's not. It was technically possible to do it with Precise already. I'm just not sure how many people actually realize it's possible. And you can also, well, we'll probably get back to that on Thursday, but you can also do nesting with unprivileged containers, and you can nest in privileged containers within privileged containers, that kind of stuff, which...
So you can just mix them all up, it sounds like.
Pretty much, yeah.
Is there any combination that's not allowed? Just to...
yeah, you can't create a privileged container within an unprivileged one, because you no longer have the rights. So I'm basically installing LXC within the LXC container. One thing we improved with Trusty, I think, is that LXC will detect it's running within itself and not use the same network for the subcontainers as the container itself. Because in the past, you would install LXC and you would basically lose your network because it will use the same subnet twice. So yeah, LXC has been installed in there. If I look, I should see, yeah, LXC BR0 is configured with an IP address different from the one level down. And then in there, I can create, say, a nested container. Let's make that Oracle 6.5 index 64.
So you're already, so okay, wait, so Steph, you guys are fast. So now, so nested is inside nesting.
So, yeah, nested is inside nesting,
Okay.
which is inside shell O1, which is on a physical machine.
Okay, cool.
So if I go back to shell O1, which for that demo can be considered as being the host, I can now do lxcls-f. You see just the nesting container. And if you do -- nesting, then you see an interesting error that I actually fixed, but is not in the current release. Anyway, so we see the nested container there with its IP address. And if we create something slightly more interested than an Oracle container, so destroy it.
So you've destroyed the nested
destroyed
one, and now what
yeah,
are you doing?
I'm recreating an Ubuntu container instead because I want
instead of the Oracle one. Okay.
Yeah, I want to show nested containers. So I could there again go into the configuration of the nested container this time.
Now, have you blogged about this stuff? What you're doing right now?
Okay. Yeah, it's part of the blog series.
Yeah, that was a great series. Definitely worth a read.
So this time I'm attached inside an Ubuntu Trusty container that's inside the Ubuntu Utopic container I first created, and installing LXC inside that one.
So do you do any caching to speed any of this up?
No, I just have a really fast server. Okay, so now I can start nested, which is supposed to be an Ubuntu 12.04 container within an Ubuntu, what is that one? 14.04.
You created
within an Ubuntu 14.10. It was running on an Ubuntu 14.04 system. And if I do -- nesting, now we see the whole stack of the nesting container, the nested container, nested container, all with their one IP ranges. So that's pretty much nesting. That's pretty fun because you can set limits on some containers and you can give access to people to a given container, and if they want to create subcontainers for their workload, they can. Now, so yeah, the next thing which you might have seen me use quite a bit here is, let's just kill all of that stuff. There.
So if you destroy nesting, it destroys all of the ones underneath it.
Yep. Because they're all part of its file system. So
Yeah,
if you kill the first one, it just
sense. Yeah.
Yep.
Okay.
So the other thing that Serge and I briefly mentioned earlier is the download template. So you can, for example, just not pass it any argument, and then you get the whole list of templates that are available. That's currently CentOS, Debian, Oracle, Plamo, and Ubuntu for unprivileged containers. If I was to switch to my own machine and run a privileged container instead, what did I do? That's interesting. Okay, apparently current LXC is broken. Okay, that's the development release of LXC, so not entirely surprised that we might have some problem. Okay, just go somewhere else then. Right. Oh, that one might actually be unprivileged. Let's see. Okay, that one doesn't seem to be really happy either.
So you said that, so is it a known bug or that you're...
On my machine, I'm not really sure what just happened. It might be that I'm missing some packages, or
It's the demo gods. This is how it goes.
Well, yeah, on my local machine, it's a daily build of my own system, so of my own branch. So it might be a bit broken at the moment.
So RoadMR, while you're trying to sort that out, I asked you about the caching stuff earlier, and RoadMR made a comment. It wasn't a question. He said he read that you have a local mirror of the archive, and a poor man's option is to install apt cacher ng and configure it in etc default LXC. If he recalls correctly, containers will be auto set up to apt get stuff from the cache too.
Yeah. So yeah, the machine I'm actually doing a demo from doesn't have a local archive, but it has a gigabit link to the archive, which is close enough. So yeah, the download template we basically build. So that's CentOS, Debian, Oracle, Plamo, and Ubuntu for unprivileged containers. We also build Gentoo and Fedora on top of that for privileged containers. All of those get built daily, at least, for all releases and all architectures. So as you can see in the listing, it lists here the timestamp at which it was published. So we say it was published. Well, last build was earlier today. The nice thing with those is that you don't need to have the bootstrap or anything like that on your machine. The download template will grab the files from the server, dump them into var cache LXC download. So if I go into Ubuntu, use that big MD64 default, then we see that I've got the root file system. It downloaded directly from the server. It's got a list of files it needs to modify with the host name. It's got an expiry. So when it actually reaches the expiry, if it has network access at that time, it's going to flush the cache and re-download the current version of the template. It also lists what files should be excluded when used as an unprivileged container. The create message that's shown when it's created, which is basically the username and password. And the configuration when running as a user and the configuration when running as root. Actually making your own server for that stuff is pretty simple. The download template itself, the download template itself takes a bunch of arguments, including a server name and a key ID, both of which have defaults for what we actually use on images at linuxcontainers.org. But you could replace that with your local server. All of the indexes are simple text files, so it's really quite simple to just do your own builds or publish your own containers locally. So the next thing I've got on my list of things to show, just checking IRC. Okay, there's nothing.
Yeah, I think there was just a question about more about setting up unprivileged containers, but as from Blood Earnest, but as
right, yeah,
we're going to talk a lot about that on Thursday. So I'll just quickly say, so today we're doing some demos. I think tomorrow tomorrow or Thursday, I can't remember, talk about what we're planning for this cycle, and then we also have a whole session for.
So yeah, the planning session is in 2 hours, I think.
Okay, the planning session's today. Okay, yeah, I couldn't remember.
Yeah, it is.
So, and then the next demo focused on user namespaces is Thursday. So Blood Earnest come back.
Mm-hmm. So one of the major features that we implemented in LXC 1.0 is an API. So we've got a C API that's used by all of our tools, but is also exported publicly. It has Python 3 bindings. We've got Lua bindings as well in Tree. And we've got Ruby, Go, Python 2, and I think Java nowadays as external bindings. So you can basically spawn a shell. You can do import LXC. That gives you the LXC Python module. You can do help LXC, and then you get all of the functions that are available. That basically covers everything that the command line tools do and some more. So say I want to create a new test container, I can do that, which just defines the container object. Now, if I want to actually create something, I can do, just remember, it's distribution, I think. Ubuntu, architecture, b64, release would be, say, trusty. Yes. Container creation template. So those are basically the command line arguments. So you need to look them up or remember them, and I'm apparently pretty bad at remembering them.
I'm not sure if Serge has a question, but he just made a comment about Java.
Mm-hmm.
I think there's just a comment.
Okay. So we see it's creating the container pretty much the same thing, same way it was doing it on the command line. Okay, it returns true, so it's created. Now you can do .state to check what's the state of a container. It's currently stopped. You can do start, container is running. You can do things like get IPs, which will get you the IP address of the container. You can also do, let's see if I can do it right. Can define a new function, which does, should actually do that before, so import OS. Do I actually need to do that? Whatever. Which does say open print of open hostname. Okay, so that function basically just prints your hostname. There. And now what I could do is do my container.attach wait function. I think is the syntax. Yes. And that basically takes your Python function and runs it within the container's namespace. So as we can see, it returns test because it actually opened its host name within the container.
So why would I want to do this, Stefan?
You may want to do that when you write a testing tool, because that way you can run all of your tooling outside the container, yet you can run functions directly inside it.
You can also use it for building things like a package builder based on containers, which is something
Yeah. That's also what LXCLS --nesting actually does. It has a function that queries all the state and returns that as a dictionary, and then it runs that using attach within the containers. So even if the container itself doesn't have a Python interpreter, it can still run the code because the code actually comes from the outside. What else can we do? So we can do things like rebooting the container. We can also attach to the console, except it was rebooting, but yes. So we can there. So it's a pretty powerful API. We're using it internally. So LXCLS is a pretty big API, Python API user. LXC device as well, and there are a bunch more tools that use that API. Probably a bunch more to come soon as well. So
and most of the commands are actually just C code using the C API library as well. So it's
it's a really thin layer on top of the C API. So if you go see the C API documentation, it should pretty much match. In any case, you can always just do things like if you want to say clone a container, you can look at the help for the clone function, which gives you the actual arguments, and those usually match those that you either pass in the command line or those that are in the C API. See if there are any questions. Doesn't look like it. So the other thing I wanted to show is what we've been doing with container configurations nowadays. So if I go and edit container config, you'll see it's pretty short, mostly because all of the bits that we know are going to change. Say some of the bind mounts we need to do, list of capabilities, all of that stuff. We basically put in a command location, and we just do LXC include for that. LXC include basically means it takes the content of the target file and parses it as if it was in line. So you can basically, you've got those two includes. If we go look at them individually, the common one is includes all of the bind mounts that Ubuntu requires, for example. It also includes the number of TTY devices we want, number of PTS devices, what capabilities we want to drop, examples as to what you can do for hooks and APAMO profiles, and then the list of devices that are allowed. Then we've got stacked on top of that, in my case, the user NS config, which is for unprivileged containers. And we see that in those, we basically override things that came from the command config. So the first two lines basically say wipe the whole C group device access list, because we can't actually set those entries as unprivileged users. And since we are unprivileged anyway, they're not really relevant because you won't have rights regardless. Same thing for devctyd. We don't have permissions to mess with some of those devices in the container, so we just clear it. And then we add a whole bunch of bind mounts inline. So those two files are first included, then the container specific config is there. That's a massive change from what we had in Precise, where we would generate maybe like 50 lines long config for every single container, which was working fine, but had the major downside that if we needed to add a new bind mount, for example, so that the container keeps on working with newer Ubuntu releases, or so that a mantle update or something doesn't break your container, we couldn't do it. We would only be able to push the fix so that it works on any newly created container, but any older container would just be stuck with whatever config it first had. So doing that kind of change helped quite a lot, and is actually has been made a mandatory requirement for any template that supports the download template. So anything you use with -t download will come with that kind of config. You can actually see that you should have in that directory. Most distros that we support have their config split in the same way. Ubuntu is actually split even more, because we've got two Ubuntu templates. We've got the main Ubuntu template and the Ubuntu Cloud template, which, if I remember well, actually includes the Ubuntu template itself. Yeah, it does. So there we see that the Ubuntu Cloud command config inherits from the Ubuntu command config itself, and then just adds an extra hook that's required to make cloning work properly with the Ubuntu Cloud template.
Cool. I think we're just about out of time, but you have a couple more minutes. And I also want to quickly mention, so I think it's been moved till tomorrow. There's a session in the DevOps 1 track called Juju with LXC containers for local development. So I think that might be, for those of you that are watching that are really interested in containers, which of course, that's why you're here, that might be worth checking out tomorrow.
Yeah, and as we said already a few times, there will be...
Yeah. Sorry.
So yeah, there will be another LXC session in 2 hours that's mostly focusing on planning for the LXC 1.1 release and what we'll have probably in 14.10. And then we've got another session, I think Thursday morning.
Yeah, it's Thursday. User namespaces, which is more
on user namespaces. Yes,
yeah, and
where we'll go in more details with Serge on how you can configure your system to run LXC as an unprivileged user. What's possible to do with that. For example, the Google Hangout session I'm using currently is actually running within an unprivileged container on my desktop machine. And yeah, we can do things a lot like running GUI application in containers. And we'll try to go into more details of that on Thursday.
Yeah, and that's why I also wanted to mention that there's a session that you guys aren't doing, but the Juju Solutions team is doing, which is, like I said, it's Juju with LXC containers. So that might be interesting. Anyway, Stefan, is there anything, Serge, anything else that you guys want to talk about?
Don't think so. I think we're pretty much good demo-wise.
Yep, that's all the topics we had, I think.
Excellent. All right. Well, thank you so much, Stefan and Serge. This is, I thought, very, very interesting. Anyway, and I think if people have questions for you guys are on Freenode. So
yeah, we're pretty much always on IRC. There is actually an LX. What's the name of the channel again? I'll never remember it properly.
LX containers.
Yes.
What is it called?
Can you paste it maybe, Serge?
Yeah. Where'd it go? There it is.
All right.
LX containers.
Yeah.
Okay,
and
cool.
yeah, the main LXC website is on linuxcontainers.org, and we've got lists linuxcontainers.org for the mailing lists.
Cool. All right.
Yeah.
All right. So thank you so much, guys, and I guess I'll talk to you both in about an hour when we'll talk about planning. So
yeah.
Take care. Thank you. Bye.
Bye.
Bye, everybody.